Hey everybody, this is Brad Dyke saying hi to you real fast. Today we're going to talk about something that I kind of have been watching for the past couple of years, and I truly, genuinely feel that it's time to say something about it. And that is GPUs, graphic processing units, GPUs. Now, a graphic processing unit is basically a programmable chip, to make it simple, with memory resources, and it can take in information and it can process it and spit it out as an output. That output, in this particular case, input output, would be video. Now, the thing about GPUs is, as neat as it is to see the 3090 and the Series 4000 GeForce cards or the AMD cards, that's really sweet. But can we put some real reality checks here? The first one is your eyeballs can only see 30 to 60 frame ratio. That's it. So it's great that you have a 120 or 160 or 180 or 240 frame rate video card, but you don't get the value from that as a human being. As much as we'd love to say that you could, that'd be awesome, wouldn't it? You can't. But that doesn't mean there isn't value for it. Matter of fact, there's a lot of value for it because of what it can capture. When you do a video capture of something, or you're wanting to render something, you can compress a lot of stuff into that, or you can capture a lot of input data, such as, for instance, 4K cameras looking over an area for an experiment. You're catching a lot of telemetry, and that's a great value. Don't get me wrong. But when it comes to gaming, this just doesn't do the job. Now, one important detail about the fact that, is there value in the GPU, a brand new GPU with all these extended features and ray tracing and so on and so on, versus my 960 here? Well, the truth of the matter is, and manufacturers of graphics video cards don't want you to know this too much, the software just isn't there for it. Now, when you look at a 1060 or a 1070, and then you look at a 2070 and a 3070 and a 4070 and so on and so on, you are going to see what's called progressionary hardware evolution. What that basically means is that the logic in the hardware is more improved, yes, and how it's routing it and how it's handling it and the processes of RAM and so on. But that doesn't mean that the software in your operating system, may it be Linux or Microsoft, can actually take advantage of it. Not yet. And that's a progressive 7 to 9 year issue we have with most platforms, even with motherboards. The evolution of taking advantage of PCIe 4 doesn't exist yet, even though the physical attributes are there and you do see some type of a performance increase. The software to take advantage of it isn't quite there yet. So because of that detail, you actually have to wait. You buy this great cool stuff. It does look like it's pretty fast, but what can it really do when you write the software for it? And that's the issue with graphics cards. That's why when you use Just Cause and you put all three cards in there, of course there's a frame rate increase because of the bus design of the graphics card, but there's no software improvement, none whatsoever, because of the fact that DirectX and other software level implementations to take advantage of all the features of your graphics video card, it's not there yet, or it's introductory, or it's still evolutionary in its initial stages. That's why, when I look at the newest and the greatest cards out there, I look at them differently. I look at them, okay, as, hey, these are programmable CPUs. Unlike a locked-in central processing unit for a motherboard, these guys actually have the ability of being blank, put my own code in it, rinse, repeat, wipe it clean, do it again, and so on and so on. That's the beauty of GPUs that CPUs don't offer. That's a great advantage. The second thing is, you've got a huge buffer of RAM that can be used for resources. Now, this is accomplished by cryptocurrency. So somebody took the function of a video card, scrapped the video mode completely, and used the input-output pathway to compile mathematical equations and to get a quantum size style key that you could turn around and treat it as an asset and sell it. That's pretty brilliant, in my opinion. So when I look at GPUs, I look at them in the total family of the processing units. That's the correct term. You've got the NPU, the network processing unit. That's on your NIC, or it's a sub card on your motherboard. You have your GPU, your graphics processing unit. You have your central processing unit. Yeah, it would be your CPU. And you have other components like an SPU. That would be a storage processing unit sitting on a RAID card. You see, the key detail here is, in this case, this is a RAID controller. It has basically SAS outputs on the side. And you have a processing unit here. And you've got the memory. And you got a heat shield designed to dissipate the heat. And of course, on the back of the card, you've got your secondary bus and you've got your secondary memory resources as well. The same thing exists here on this exact platform. Now, this does get hotter because we run it hotter, so it has a much bigger heat sink. But basically, in a nutshell, as you can see, it is exactly the same thing. So when you look at things, even USB cards, even when you take a look at something as simplistic as a Raspberry Pi, as you look here, it also has its resource, its heat sinks, its memory, its chipsets in regards to how it's going to process its data, and it itself is the same kind of thing. The key here is buy something that gives you the performance you want, but make sure the software is taking full advantage of that. Now, what does that really mean at the end of the day? Well, the truth is, if I look at a 4000 series GeForce, which I do gravitate more to GeForce than I do AMD, nothing really wrong with them. Principally, they're the same strategy. I look at this GeForce and I see the 4000, and then the 3000, and then the 2000, and then the 1000 series, and then the 900s, right? So then I look at the standing of the card itself. The more, bad news, but the more CPU fans that you see on a video card, the worse the GPU is. Well, basically what they're doing is they're taking a standard GPU and they're overclocking it so heavy that it requires a huge amount of heat dissipation to get rid of the heat. If you get a video card that respect to its heat, then you don't need 3 fans. 1 fan and a central thermal piping heatsink will do the justice for it. And all of a sudden, my costs get under control really quick. Why? Because the software I'm going to use, let's say DirectX or SetX or Phoenix or something like that, those roles that they're going to do is going to generate 80% usage of my video card, and I'm going to get great performance of that, but I'm not overclocking or stressing my chip to the point where I need 3 heat sinks or a large heat sink and 3 CPU fans, style size fans. And, I've already looked at a program of death when it comes to such a large heat sink with 3 fans. I know I have a defined end of life for that video card, but it's $700, $800, $900 for the card. No, not going to happen. Do it smart. Look at your software needs. Understand a really great performance for what you want. If you like gaming, 60 frames, excellent. 60, 80 frames, overkill. Good resource for memory. Understand that you're gonna do cryptocurrency. You're going down one different path of higher memory requirements opposed to gaming. And then you look at the cards themselves, and I tell you that when you see a card that is rated at a specific make and model, but it only has 1 CPU fan-like size fan, as you can see here, with the thermal heat pipe configuration, this is the smarter design because it doesn't have as great amount of heat. And therefore, you're actually getting a nice long life video card that can meet your requirements. I have progressed up to the 1070 card at this point in stage because the reality is the GeForce 1070s, the 1080is, TIs, and so on are really just starting to really get used when you look at the software. I'll eventually go into the 270, but it's going to be a while before I go to the 3000 series because, frankly, in a nutshell, you can't get real advantage of what those features and functions say they can do versus what you can see and have the software to work with. Well, this is Brad Dyke. I just wanted to touch base with you on this. This is something that it's all starting to settle down out there in the world of GPUs. But the reality of the fact is, it doesn't matter if it's a GPU, an NTU, or I'm sorry, an NPU or a SPU or a CPU. The way it deals with its heat, its design versus the software that's written for it, and actually can take advantage of that resource is the right way to go every single time, because at that point stage you're not spending money unnecessarily. A great example why the LSI 2000 series SAS controllers and HBA controllers work so wonderfully is because finally ZFS and other software platforms are actually developing much more in-depth code for storage. And wow, we can reinvent these controllers to do completely different things than they used to be done in the days of enterprise storage. Well, this is Brad Dyke. I'm signing off. God bless, and I hope you guys have a great week.